Let us now look at fire-resistant coating of metal. Temperatures generated during a fire generally exceed 1000 degrees Celsius. Steel becomes 50% less stable at a temperature of 500 degrees Celsius. Before beginning with the application of the fire-resistant coating, the HP to A ratio must be computed and the coverage quantity specified in accordance with the permit certification. The primer coat is tested for suitability in conformity with DIN 55928. The HP to A value is the ratio of the heated perimeter, equals HP to the cross-sectional area equals A of the steel building component. This maximum permissible ratio specified in the certification permit is 300 to the power of -1 meters. We provide a sample computation of two standard steel profiles, IPBL and IPBV, with a nominal height of 200 millimeters. Accordingly, the left profile has a circumference of 1.14 meters and a cross-sectional area of 53.8 square centimeters, resulting in an HP to A ratio of 212 to the power of -1 meters. For the profile shown on the right, we have computed a heated perimeter of 1.2 meters and a cross-sectional area of 131 square centimeters with an HP to A ratio of 92 to the power of -1 meters. The lower HP to A ratio of the right profile is attributable to a higher mass of steel, which results in slower heating in the event of exposure to fire. HP to A values can be read from tables relating to profile types in order to avoid having to compute the value for each individual profile. It's important to determine the maximum limits for the HP to A ratios in order to specify in the permit how much fire-resistant coating material is to be applied to the steel building components requiring protection. Example: for an open filigree profile with an HP to A ratio lower than 300 to the power of -1 meters, Henseltherm 3KS-HF must be applied with a coverage rate of 930 grams per square meter, equaling 500 micrometers dry coat. For open profiles used as girders and for supports and compound framework structures with an HP to A ratio of less than 100 to the power of -1 meters, the coverage quantity can be reduced to 650 grams per square meter, equaling 350 micrometer dry coat. The coverage rates for closed profiles are set at 2,790 and 1,200 grams per square meter respectively. The following procedure is used to compute the HP to A ratios of closed profiles on the basis of a simplified method described in DIN 4102 Part 4. 100 divided by T. T equals wall thickness in centimeters. The table shows that wall thickness of 0.50 centimeters, for example, produce an HP to A value of less than 200 to the power of -1 meters. The fireproofing system consists of the following layers: primer coat to protect against corrosion, intermediate coating as fireproofing layer, final coating as a top coat. The anti-corrosion coating must have a sufficient thickness of 50 micrometers, which, if not achieved by transport primer coats, must be added before further processing. Anti-corrosion coatings of this thickness must be further processed with subsequent coatings within 3 months. If the structure is exposed in unprotected conditions for at least 3 but not more than 10 months, the thickness of the primer coat must be increased to 100 micrometers. The anti-corrosion coating must also bond firmly with the undersurface. Bonds can be tested using a grid section. In this case we have good bonding and a grit section value of GT1, that is less than 5% surface flaking. In the second example, the bond is very poor, with a grit section value of GT4, that is approximately 65% surface flaking. In the interest of fire safety, a primer coat must not separate when exposed to heat, as these are fire safety coatings that must remain effective even under exposure to extreme temperatures. You see both a positive and a negative result. A scratch test is used to determine that the fire-resistant coating bonds firmly with the primer coat. Galvanized steel surfaces are also suitable for fire-resistant coating, provided the galvanized surface is pre-treated, cleaning with steam jet or by sweeping, and then coated with Hensel 3150. Hensel 4KS is a water-based coating for F30 and F60, both as open and closed profiles. Hensel 3KS HF is a solvent-based coating for F30 but contains no halogens. These products must be processed and applied in dry areas only. It's essential to ensure for all coating procedures that the temperatures of the steel are above 5 degrees Celsius and the relative surface moisture is less than 80%. Steel temperature must be at least 3 degrees above the dew point during application. Transport and installation damage on the otherwise intact primer coat must be repaired, of course. So much for the necessary preparatory tests. Let us turn our attention now to the actual fireproofing process at the construction site. The technical data sheets specify that all materials are to be thoroughly stirred prior to use. The spray applicator system must be bled of air before spraying in order to ensure that the coating material is conveyed to the nozzle. The electronic pressure control unit regulates the desired spray pressure. We use a material pressure of 200 bar and a working pressure of 190 bar, a spraying distance of 30 to 40 centimeters, and a nozzle size of between 0.017 and 0.027 of an inch. And we protect ourselves with a half-face mask, protective goggles and protective gloves. For a coverage quantity of 930 grams per square meter, which can be applied in one coat, depending upon the characteristics of the profile, it is essential to check during the application process to ensure that the required coverage is achieved. At 930 grams per square meter, we have a wet layer thickness of 710 micrometers, and thus the possibility of limiting the maximum application quantity. Insufficient application requires a second coating procedure. The nozzles are selected with different spraying angles, 20 and 40 degrees. The expulsion quantity remains the same. The spraying angle depends on the specific object being coated. The process of coating an open profile involves the following steps. Spraying the upper interior flange. Spraying the lower interior flange. And the bridge. The distance from the spray nozzle to the object influences the quality of the coated surface. We see the difference between an insufficient distance and an optimum distance. Now a few tips on handling the spray gun. It's not advisable to hold the spray gun pointing upward and spraying in an arc, as this creates excessive spray fog and leads to non-uniform application. The correct procedure is to hold the pistol at a 90-degree angle, moving it parallel to the surface. This reduces spray fog and we achieve uniform application. Coverage quantities for fire-resistant coating of open and closed profiles are specified. The required layer thicknesses are listed in the permit and in our technical data sheets. When checking to determine compliance with the thickness requirements, it's important to add the thickness of the primer coat to the total. These measurements must be taken before applying the final coat, so that corrections can be made without difficulty. Once the fire-resistant coating has been properly applied, the system is given a final coat of Hensel Top 84. This coat protects the actual fire-resistant coating against environmental influences and provides the architect or client with the opportunity to achieve the desired color design. In addition to the standard colors offered by the supplier, the architect may opt for any RAL, NCS or special colors as desired. All structures treated with a fire-resistant coating which forms an insulating layer must be identified as such by one or more weatherproof signs. Several signs at major construction projects. The signs must contain the following information: date of permit, permit number, number of coating layers, date of application, name and address of the firm that performs the work, designation of the final coating, date of inspection. In the construction site testing record, the firm performing the work in question documents compliance with layer thickness requirements for the fire-resistant coating applied. In order to ensure that goods delivered to the construction site retain their uniform quality and effectiveness, every batch produced must be tested in a standardized small fire test rig in accordance with specified standard procedures. This testing involves the coating of a test plate with material from the batch in question. The material test is conducted according to the following procedure. The coated test plate is mounted in the furnace opening. Then it is insulated from the rear with two vermiculite panels, each 5 cm thick. The temperature sensor affixed to the center of the steel plate is inserted through the insulation panels and connected to the electronic measuring unit. The fire test is run as a computer-controlled process in accordance with the ETK uniform testing criteria in the small fire test rig, which meets the requirements of DIN 4102. The temperature graph shows 3 temperature curves: the standard temperature curve, top, the temperature curve for the untreated steel, middle, and the temperature curve for the temperature readings taken on the rear surface of the steel plate coated with Hensotherm 3KS HF, bottom. In small fire testing of coated steel plates, a temperature of 500 degrees Celsius in the center of the plate on the side not facing the fire must not be reached until the time specified as the basis for award of the permit has elapsed. Hensotherm 3KS HF and Hensotherm 4KS are fire-resistant coatings which form an insulation layer. Exposed to high temperatures, these materials form a non-flammable foam from a coating layer of only 350 micrometers. This foam swells and thus protects the underlying steel against rapid heating. Depending on coverage quantities, we achieve foam thickness of between 3 and 6 centimeters. These special coating materials are available for interior and exterior applications for categories F30 and up. They are to be applied only by qualified personnel who have been familiarized with their use in intensive training courses provided by the manufacturer.